Hi, everyone. I guess we could slowly kick this off. Welcome to the first ever international SGA online workshop. I will also invite my co-hosts here today, Nina from the SAE Institute Belgrade and Andrea, our presenter for today. They will have a chance to introduce themselves very soon. I just wanted to welcome you all again. It would be great to hear why you decided to join us. If you have any questions up front, you can feel free to use the chat option below. And I would also ask all of you to keep your microphones muted so we don't interrupt Andrea in his presentation. So I'm guessing all of you are interested in video games, but we also hope that there are maybe some people from the film industry as well. Nina, would you like to say a few words about the SAE, how you decided to cooperate with us on this meetup, and then we can pivot to Andrea.
Definitely. Thank you very much, Christina. And thank you all for being here tonight with us. As Christina said, I'm Nina and I'm here on behalf of SAE Belgrade. For all of you who don't know, SAE Institute is the world's largest private college with more than 47 campuses around the world. It is founded back in 1976. SAE Institute Belgrade celebrates 10 years anniversary this year, and all this time we had actually 4 degree programs, and those are game art and VFX animation, digital film production, audio production, and web development. Apart from these degree programs, we also offer short certificated courses from all of these areas. Today, we are happy to have this opportunity to collaborate with our friends from SAE Milano. In this way, we will share this SAE global spirit with through this SGA workshop. Thank you, Andrea, very much for being here with us to share your knowledge with Serbian gaming community. And thank you, Christina, also so very much for helping us to organize this event. Thank you guys for being here, and I really hope you will enjoy.
Thank you, Nina, for the great introduction. As you could hear, SEA has some very interesting programs for the gaming community, and I hope some of you will check it out. Also, you can reach Nina on our official SGA Discord channel. She's always there to answer all your questions. But besides that, we have a very rich and active gaming community over there, more than, I think, 550 people right now from all areas. You can always join us and chat with them. So Andrea, welcome again officially from me. Would you like to tell us a few words about yourself, your work at the SAE Milan, and what you have in store for us today?
Yeah, hello everyone. Nice to meet you all, also in this virtual setup. And actually, well, I am in SAE Milan. I am the film and game department coordinator. So I work closely with lecturers and tutors in developing the program, and also in the research of new techniques and new technologies that we can bring to our students. And that's what a part of what I wanted to talk about this evening. I will start with just a brief presentation on motion capture and how it evolved and how it can work today with inertial sensors. And then we will go through a live demonstration of the use of a Rokoko Smartsuit and how it can communicate straight to Unreal, so we can see our character in-game engine moving and meanwhile recording the movement using the Rokoko native software. Just as a beginning, I wanted to, as I said, introduce a few concepts, and in order to have everyone here the basic knowledge on what is going to happen today and the workflow we are going to use. But also, first of all, I wanted to introduce what actually is motion capture. And to do so, I wanted to discuss where motion capture came from. This is really, really important because motion capture is a concept. It's actually a really old concept in gaming. It started with rotoscoping since the fourth Prince of Persia, so it's like 30 years that it's around, but it evolved. It evolved mostly movies, and then came back to game and go back to movies for ages. And now it has become something that also independent game makers and filmmakers can use in their job, in their productions. Basically, the concept is to be able to transfer the motion information from a person, so from any kind of live action source that is recorded or live, so tracked live, to a CGI element. This means that we can apply human movement or animal movement to any kind of game asset. Of course, the game asset must be coherent with the movement we are doing. So we can't apply a human movement to an animal because the physical shape is different. We have to change the shape of the actor. At the same time, we can adapt the movement to distort the measures of the actor. Actually, we can work this in many different ways, and it all depends on the production pipeline and the animation software we are going to use. And for that, there are mainly free master kind of motion capture. The eldest one and well, actually the harder is using a tracking system. This means to have tracking points, so small dots on the subject that we can afterwards transfer using a tracking software to a 3D character, or actually it was mostly used for performance capture, so the motion capture of facial expressions and stuff like that, since well, Avatar in 2009 was a pretty good example, but also movies like Pirates of the Caribbean and stuff like that. But it's a really complex method because you always have to shoot the tracking points. You can't lose them in the shooting. So this requires complex cameras and complex setups and helmets with cameras in front of the face of the actor that makes really complex movement. It's the only way actually right now to have a performance capture, so it's not just for body motion but also for expressions. But for body motion, it has been since long overclassed by more precise and reliable systems. One of the systems is the passive optical system. Is really similar. It's been used for movies and also for the production of since the first Assassin's Creed in gaming, and it consists in a special suite with sensor which responds to UV lights, and you need a camera rig all around the subject in the studio where he's moving in order to get the motion. This system is really precise, but it's really complex, really expensive, and it's really difficult to use on location because you need to build the whole rig around your character. And then there are the inertial systems, like the one we are going to use this evening, which are based on new technologies that we have everywhere. We have them in our phones and in our tablets and nearly in our GPSs, in our cars. And basically it can be really cheap. So a good inertial system might have a price of about between 2,000 and 5,000 euros instead of the 20,000 plus for a an optical system, and also it can be mobile, because we don't need to shoot the subject. We can import the movement straight from the suite, from the rig. So we can do it anywhere. We just need a wireless connection, and that can be done also using the hotspot from the phone. And we actually need to put on the suite, and the suite is based on sensors, which are nearly this big, and basically they have inside a gyroscope, magnetometer, and accelerometer. So like in the phone, they measure the movement of the single sensor in the space, and then the software, the native software of each different system is able to reconnect all of them and connect them together and transfer them to an animation rig. In many softwares, it can be exported to Maya rigs or Mixamo rigs or generic rigs that can be then applied in different softwares like Motion Builder or straight inside real-time engines like Unreal Engine 4. The workflow is actually quite easy, and it requires a bit of planning in the beginning. Then it requires to connect the different technologies we are going to use and the different softwares. A recording phase, because anyway we can see the movement and we can see the rig moving inside a real engine, but we are going to record it inside the, in this case, we are going to use a Rokoko Smartsuit Pro, so we are going to record it in Rokoko Studio. And anyway, a cleanup moment. So we will need to export our rig, bring it inside our favorite animation software. It can be done in Maya, in Blender, or in Make Human too, and we need to clean it up. So it's really, really important to plan the action ahead, so to have a script or a storyboard or a precise plan of what we are going to record with our MoCap system. Also, for a simple recording, it's necessary to have a script or something to follow. It's easier with the seeing how immediate it is to connect all the things and to see the movement. It can look really easy, but really it isn't. A good planning is essential. The good thing is that we can do the recording, as I said before, everywhere with inertial systems. We can do it also on location, and that can be really helpful if we have to simulate spatial movements like running or gymnastics or parkour. We don't have to build a big infrastructure inside a studio where we can do these things. We can do them outside, where we have a boulder, or we have a wall, or on a hill, or on the street. The other important thing is having a system that can be coupled. This means that we have to check with attention what hardware we have in our machine and the needs of the specific inertial system we are going to use, and also how it can communicate with the software where we are going to send it. Actually, if we don't want to have a preview inside a real-time engine, some things can be a lot easier, but that's something that we have to check earlier, and also if we are not watching it inside the virtual environment, we have more than in any other case, have a good planning of the movement we are going to record. Anyway, we will need, after having set everything up, we will need to record inside the MoCap system. Many MoCap systems and native softwares have their own ways to clean up the recording, and this ability to clean up the recording is something that we can, well, it's really useful if you want to show to your client or to the production a cleaner movement or a better movement, so they can understand better what is going to happen in the final animation, but is not just as precise and rich of controls as if we go to clean up everything inside an animation software. So after we have done the recording and checked everything, we have a mandatory passage, a mandatory step inside an animation software. And that's something that must be done by a good animator, because the animation that we get with a MoCap system is going to have a high number of frames per second. It depends on systems, but they usually run between 60 and 120 frames per second. So a really high frame rate, and that's of course because we need precision both for film and gaming, so the movement must be really precise, but that also means that each of these frames will have a keyframe for each joint that is in our rig. So the animator will need to manage the relationship and all the IK he has in his rig in order to clean everything up. Basically, you can see me here, green back, and actually this is the basic suite. It's a black suite, and the system is done this way. We have all these sensors, like the sensors are this big, and inside this sensor are all the connections and all the inertial systems, and everything goes through an hub that is posed in the middle of the back of the performer. So you just have to actually plug this inside the computer, usually, and connect everything up. And the suite is quite easy to use. You can just open it up in the front and put it on, and this is the funny part of the work. It's not really heavy, and it's kind of hot inside, so in summer it's kind of more difficult to use. But basically, this is the actual suite, and when you wear it, you find different sensors around your body.
So in the tracking system you mentioned, that's the oldest technology for motion capture. You use dots, and that makes everything more precise but more difficult to use, maybe for smaller teams. And here it's just enough to have a couple of sensors that track your movements, right?
Yeah, exactly. The good thing of the sensors, a full rig is around between 24 and to 40 sensors. In here we have many, and now I will explain where they are going to fall all together. Just when you put everything on, you need to have sensors all around your body. So you have sensors that goes from your foot, and one needs to be exactly in the middle of the foot, then in the middle of the leg, on the right and left leg, lower leg, upper leg, hips, back here, in the back, on under both shoulders, on the shoulder, in the middle of the upper arm, and also in the middle of the forearm here and on the hand. So, and that's of course for both sides of the body. And finally, one for the head that needs to go behind the head usually. With this kind of rig, you can actually track all the movement that a person can do. It can work, it can read all the movement, and it reads the difference between the sensors. So this sensor is going to move in a way, this sensor in another, and the difference between this sensor means that the elbow is turning in a way and not in the other way. So reading the movement of different sensor, the system is able to understand what is happening and what movement we are actually doing in the scene. So the suite must be usually plugged through this system back here, and when plugged, it works normally with the software. It reads the software, and it gets opened inside the Rokoko software, and then from there we can send it off to an external application. In this case, I will show you the blueprint in Unreal Engine, and
so just to clarify, it imports the recording directly into the engine, or first into its own software, and then you have to port it to Unreal or whatever?
No, we can see the movement directly into the engine. This is this blueprint setup to connect the Rokoko Smartsuit to Unreal Engine. So basically, we need to use a few nodes. It's just 4 nodes, so it's not a complex blueprint for Unreal Engine. And we need to, we have a node that we have to install into Unreal. It's a native node, it's a plugin, and then it gets the control of the rig of our character. And once this blueprint is compiled, the output is the pose of the character. So basically, all the movement we do gets shown in the character here.
Welcome to this upgrade on the contents we discussed inside the webinar. And what I'm going to introduce is the actual workflow. I made the Smartsuit Pro work again, so everything is fine now, and I had to reset a couple of things, but everything is working. What we are going to do in this add-on is to create a new body profile, a new actor profile for another performer, and then connect it straight to Unreal Engine, record, and then import again the recorded file. Basically, we need to create a character profile, put inside the name, choose a color for the character profile, but mostly choose a body type. The body type is important because it's how the software is going to recognize a male from a female. We have a female performer today, so we are going to set it up on her measurements from height to every detail in the body profile. And once everything is inserted, we can save the body profile and then go inside the project to associate it with the Smartsuit. The Smartsuit is now connected. It's not what you see. It's all messed up because we have to perform an A pose in order to position everything. But first of all, we have to link the MoCap suite with the correct body profile. So now it's connected with another body profile that is saved on my system, and you can see how the sensors are working. And basically, we have to open the body profile and switch body profile. Now it's reading the new body. Of course, we have to position the basic position for the Smartsuit. So we have to position inside an A pose, which is a straight up pose, in order to have control on the rig and tell the system this is the standard position of all the sensors. If not, everything stays kind of messed around. In the body profile on the right, you can see a few yellow sensors. Yellow is not good, but it's not even so bad if there are not so many. It means some things are not, we have a bit of interference and some things are not working perfectly, but for what we have to do, a bit of yellow is not too bad. So now we are going to perform the A pose, just clicking here, and we have to stand still, and once it is done, the performer can start moving, and all the movement will be transferred straight to the Rokoko Studio software. So at this point we can start working also with a real engine and connect all the elements together. So we see the movement in Rokoko, we don't see it yet inside Unreal Engine, and that's because we have to connect the two systems. And in order to connect the two systems, we have to install a plugin, a free plugin that is already there, and we have to make a blueprint, an animation blueprint that can read all the things in and out. The animation blueprint is already there. I have to insert inside the project a Smartsuit receiver and the Smartsuit controller in order to connect everything. So I'm going to look for them in the Asset tab. It's Smartsuit. Here it is, the controller, in which we have to indicate the name, the actual name of the Smartsuit. It's QLA, the nickname of our Smartsuit, and it gets an index number, and also the receiver. The receiver needs to be connected to the Smartsuit, so it needs to have the same IP as the Smartsuit. And now we can see that we have a complete blueprint in which the information from the Smartsuit is sent through a mapping to the Unreal skeleton, and the ID should be the ID of the Smartsuit, so it's the name or even the actual number. And everything is nearly set up. We have to go to Rokoko Studio and turn on live stream, which is already on right now, but we need to set the port number. It's 14043. That's the port number, the listening port number. We have to set inside the receiver in Unreal Engine in order to have everything working. It's really important to do so, so we can close this tab and switch over here and open again the controller. Okay, the controller is set, and let's open the this is the setup of the Smartsuit. Okay, and we can simply open the receiver. The name is right, auto connect active, and then the receiver, and put inside here the free at the end instead of the one. And once we've done this and we go live in the viewer inside Unreal, we can actually see the movement. The character moved because the position in the space is not the same, and it's over there. It's floating right now. That's not too much of a problem, but we can see the movement is right, so probably it's just a position issue, so we just can stop and restart, but we can see that the movement is quite good, and the movement is good in here too, so we can record it if we want. It's a take one. Then what is happening inside Rokoko Studio is being recorded and also seen live inside Unreal Engine. Just let me get out of the viewer, and let's get out and get in again in order to... Okay, get out, get in again, and everything should be fine now. Yeah, the distance from the floor, it was a rendering problem, so we can stop and automatically start a new and start new recording straight away, and automatically the software will do a second take. And now we are actually recording our official take for today's webinar. All the movement that is done can be done everything. Walk cycle, gymnastics, or a fighting scene, or fight moves, or anything from something really simple and really easy to some things really complex. We can have our character dancing and running and fighting and driving a car, or just sitting on a chair and waving his hands, and everything we do will be we can check it inside Unreal Engine and we can see it live, and also we can, as we are doing, record it inside Rokoko Studio. This means that what we're doing is not locked inside Unreal. We can work it a little bit more later on, and now we can go back. We've recorded a little bit. We can go back and stop the recording, and we have all the movement. And if we double click on the take, okay, it processes the recording, and here it is. We focus on the character and we can see all the recorded movement. Everything we have seen applied to the character in Unreal, it's now visible inside Rokoko Studio. The two tracks, the green and blue one, are the locomotion tracks. It's left foot and right foot, and they are controllers that we can use inside Rokoko Studio to clean up a little bit the movement, analyze the movement, and basically if we have jumps or stuff like that, we can work on the locomotors in order to control the character getting off the ground, and we can check that the movement is okay. Every time it goes on the ground, they turn on, so everything is working pretty fine. And also we have another track underneath. It's the two bend. It's the ability for the rig to do this movement on the foot, so it can bend actually the foot, and it's not a rigid body. And that's something it's useful for animation more than game animation, and we can keep it. It's not such an issue. And then we have to export it, so we can export. We are going to have an FBX without anything, just AC, mix some rig, no trackers, no face, no body mesh. We don't need any of that. and just click export, and it will be really quickly, it will export everything. So analyzing from T-pose to everything else, and that's the clean out character. Okay, that's perfect. And then we can apply it to any character inside Unreal Engine. We just need to well, connect it or import it or connect it or straight to the character we already seen or to another character. So we go back to Unreal and just import another character. It's a Mixamo character that I used a few times to test, and it's good. So we import the character, import all, and well, actually I should have imported it inside the folder. It's going to I'm going to have to move all the assets to a folder to keep the project a little bit more ordered. Everything is going to pop out here. We have a few issues, but that's not a problem. We are not going to use those animations, so there is no problem at all. And we create a folder, we call it girl, and we are going to move everything inside the folder. So we take everything, texture and bump map, and we get mesh and move it inside the folder. And now our character is all inside there, and we can see it, all the things. And we can go back to the main contents and create another folder we are going to call MoCap, in which to import the FBX we exported from Rokoko, and just right click, import FBX, go to Documents, and down to Smartsuit Studio, and to Webinar, which is our project, export, scene 1, take 2. And it's going to import the animation. We are going to tell it now which rig we want, and we want to use the girl rig, and import all. And actually what we will have is an animation clip. An animation clip we can manage and edit and work with inside Rokoko, inside Unreal. Just a few instances to finish the import. And here we are. We have a problem with eyes. Of course, we don't have an animation for the eyes, so that's not a problem. If I double click, it's compressing the animation, and now we have our actual animation from the rig transposed to the character. There's a bit of deformation here and there, but basically it's quite right. The arms are a bit long, but it looks quite good. The feet have a few problems. We should have had a run inside Maya or Blender or any other animation software in order to clean things up a bit. We can also clean things up a bit straight inside Unreal Engine. We have a few controls that we can use in the animation editor to manage our animation clip. So we can add layer tracks and manage animation course in order to modify a few things. Well, that's completely another argument, and it should take a really long time, but everything works fine, and this can be already useful in order to have a quick real-time animation and the ability to check if what we are doing in animation and it's fair and it's working with the character and with everything else that we need to implement in our project. It can be helpful for both game developers, filmmakers, and people like that, because, well, you see, doing this animation without a motion capture rig would have taken hours, and we actually can do it in a quarter of an hour, so it can be really, really quicker and really easier to work. Of course, it's easier to work with the basic animation, and as I said during the webinar, everything can get a little bit more complex, and the cleanup can take quite time. Well, thank you for following up with me on the animation and on the system to work between the MoCap software, Unreal Engine, and the import and export of FBX animations, and hope you enjoyed.
And after the recording is made in Unreal, how easy is it for animators to take over and to do their job later? Let's say later on in the pipeline.
Well, inside Unreal, we can see the movement, but we're not going to record the movement in Unreal. Where we record the movement is inside Rokoko Studio, which is the main software from Rokoko, and once inside Rokoko Studio, we can record and export. What we're going to export from Rokoko is or an FBX, so an FBX rig with animation that can be opened in Maya, and after it has been opened in Maya, it's quite simple to clean up. Or for a change, we can also export from Rokoko a Mixamo rig. Mixamo can, many people knows it, but it's a platform where we can upload and share characters and also animations, which can then be used, looped for games or for instances. And what we can do is that we can work on the FBX rig that we take out of Rokoko Studio and bring it inside, well, actually, for example, Maya or Motion Builder, and clean it up. The cleanup, it's not so easy. If we are working with Maya and we export an IBK setup for the rig, we can use the IBK system in Maya to clean it up. It's a long work, and also we have to consider that if in a suite like this, we don't have all the animation. So some animations like fingers or facial animation must be anyway done manually, in this case, by the animator. So there's still a lot of work of animation that must be done in order to have things up and running and have a loop that is usable inside the game engine later on. The good thing about MoCap is that it's not going to solve all the issues in animating a character, but can make a part of the animation a lot quicker, like walk cycles or jumps or something like that. And also it can make it more real, because the important thing that MoCap can do is to bring forward and to show to people the physical side of movement. And that's really where it can be a game changer also for a small studio, because the work behind an animation and also the work of an animator to make an animation from scratch is really complex and really long, and also for independent studios and small productions to find good animators, it's not so easy. There aren't so many good animators around, and particularly character animators. It's a lot easier to animate 2D characters, but or motion graphics or something like that, but 3D character animation, it's kind of complex, and also creating an animation set that is going to give people the sense of the movement and the sense of what the movement is actually inside the what it feels to move like that is really, really difficult.
Great. Sorry to interrupt. Thank you for clarifying. And also for some of our members of the community who are just starting using motion capture and introducing themselves to the technology, are there any resources you would recommend? Where can they start? Any websites, any good, maybe YouTube channels with tutorials and something like that?
Basically, the first place to start is, well, two places. It depends on where we want to go with our system. One option is to try to contact directly the developer of the technology, and also to use their knowledge base, which usually is also a lot made by users. There's a lot of, it's a fresh community, so there's a lot of exchange and of experimentation and stuff like that. And on the other side, if you want to bring it inside besides software like Unreal, the best thing is to share your experimentation and all the techniques with the Unreal community. The nice thing about this technology is that it's really, really new. Also for it's really new for the indie developer. So it's not new for big studios with dedicated system, but it's new for small studios, individuals, and single developers. So there's a lot of exchange greatly inside the community of the technology developer. So that is the first place to look for information and for exchange, because if you have an issue, probably someone else had the same problem before you.
Exactly, yeah.
And maybe you can solve it together. I was using the suite something like 6 months ago with some students, and they were having a problem that basically this movement didn't work, and every time they did this, the arm get inside the body, and they couldn't understand why. And we went to look and to ask in the community of the Rokoko community, and another guy had the same problem, and it was related to the metal in the room, because it's all Wi-Fi, so everything metal or just also maybe a phone can interfere with the connection. And it was really a small problem. It was really easy to solve, but nobody had thought about the metal. So, but somebody else before did. So that's really the best place to work, is to work with the community, and that's really cool about this thing.
That's great. Great. Well, then thank you again. And like I said, our Discord link is in the chat. Maybe you can also join Andrea, why not, and be there and say hi to our Serbian community. Nina, again, thank you so much for organizing everything. And I hope this is only one of the many, many presentations we'll do together with you guys.
I hope so. And thank you, Christina, very much. Andrea, once again, thank you for your time. And thanks everybody who joined the event.
Thank you everyone who joined us. And thank you, Andrea, one more, and Nina. Bye, guys.